Chapter 3, Section 4. Learn to represent functions with tables, graphs, or equations. Our essential question, how do I make a function table? You can see we have a lot of vocabulary terms, and we'll break those down into what each one means. First term is relation. A set of ordered pairs is called a relation. Think about the word relationship. When we have ordered pairs in parentheses, we have x and y values. So example 3, 5 is called a relation. It means that they have some sort of connection. Domain is really as simple as looking at the x values. So our domain values, if we were to list them, would be -1, 0, and 1. Simply the x values. Then the range would be the y values, 0, 3, and 6. It's like looking at what sort of numbers you have to work with when you're going to start graphing. You need to know your lowest number, your highest number of your x and y values. So your domain shows you your x's, your range shows you your y's. A function, which is our key word today, is a special type of relation that pairs each input or domain value, x values, with exactly one output or range value or y value. There's two diagrams below. One shows a function, one shows not a function. On the left, you can see what a function looks like. What's important is that the x values are all different. So 0 is pairing with 3, 1 is pairing with 4, 2 is pairing with 5, 3 is pairing with 6. What I want to emphasize is that the y values really don't matter. As long as all of the x values are different and they're pairing with any sort of number. Now over in the not a function example, you see that 0 pairs with 2, 1 pairs with 4, but then 1 also pairs with 6. And have you ever solved a math problem where you put the same number in and got a different answer? That doesn't happen very often. So it's not a function, because a function is what we're used to working with, where we plug a number in, we get a response out. We don't expect that response out to change if the function, if the input is the same, So what does this mean in normal terms? Well, it's like saying, okay, I have x plus 3. So if we put 0 in there, we get 0 plus 3 equals 3. If I put 1 in there, 1 plus 3 equals 4. If I put 1 in there again, 1 plus 3 is still going to equal 4. It doesn't change. Not a function is saying if I put 1 in, the first time I get 4, the second time I get 6. So if you're just looking at a diagram similar to this, you want to check the x values. Some functions can be written as equations in two variables. The independent variable represents the input of a function. The dependent variable represents the output of a function. Input, output. Excuse me, we're missing a T there. Let's put that in. In the terms that we're used to, independent variable would be your x value. Most of the time when we're working with functions, we say, what would x be? Let's let x be something. And our dependent variable would be our y value, because y is usually the answer, the solution, which depends on what you choose for x. So we have independent, dependent, input, output. Let's determine if the relationship represents a function. Look at the x values. Are they all different? No, we see repeated x values. And within that, we have 2 pairing up with 3 and 2 pairing up with 6. We have 3 pairing up with 4 and 3 pairing up with 5. This does not make any sense. This is not a function. Let's look at the next table. Check your x values. 0, 1, 2, 3, they're all different. The y values are irrelevant at this point because all of the x values are different. So this one is a function. When we're looking at a graph, we also have a way to check. Because a function has exactly one output for each input, you can use the vertical line test to test whether a graph is a function. If no vertical line intersects the graph at more than one point, then the relation is a function. If any vertical line intersects the graph at more than one point, then the relation is not a function. Vertical line test, that's an important term. You're going to want to have that in your notes. And you're also going to want to remember a vertical line is one that goes up and down. So let's try it out. We have a graph. Determine if the relationship represents a function. Vertical line would be up and down. So we already have these blue lines, but what you're trying to imagine is if I draw a line straight up and down through any point of this graph, and by graph I'm talking about the red line, I should only cross one time. So here I cross the red line once, here I cross the red line once, here I cross it once, once. There's no way with a straight vertical line that I can ever cross that line twice with the same line. So this passes the vertical line test, so we would say the relationship is a function. Every input's giving us its independent output. Okay, what if we have this graph? If I draw a vertical line right here, I cross through the circle or oval once and twice. So this is not a function because I cannot cross through only one time. One more note about vertical line tests. This could work with anything. So if part of the graph doesn't work, the whole thing doesn't work. So we could have a straight line and then curve, which you don't see very often. But if this part right here has two crossings, it's not a function. So the whole graph has to work for the vertical line test. Okay, let's get to our essential question and make a table. We want to make a table and a graph of y equals x plus 1. We've made tables before, and this is how we set them up. We have our x column, x plus 1, and then y. And if you remember, we also added an extra column, and this will help us with our graphing of x comma y. So let's fill in our table. Now, where did the x values come from? Those were just chosen. Because we weren't given any x values, we get to choose our own. Typically, it's a good idea to have negatives and positives so that you can see what happens on both sides of the axes. Usually I would start at -2, but for this one we'll start at -1. So if x is -1, our first input, -1 plus 1, gives us a solution of 0, and our ordered pair for that would be -1, 0, which you can see on the graph. Let's look at our next point. 0 plus 1 is 1. So our ordered pair is 0, 1. Second point's on the graph. Third point, 1 plus 1 is 2. So we're going to graph 1, 2. Fourth point, 2 plus 1 is 3, 2, 3. You should start to notice a pattern, and if it's a function, it should be in a straight line most often. Let's try a little more challenging table. Make a table and graph of y equals 3 minus x squared. So we'll put our numbers in. Now we're starting at -2. We'll make our fourth column of x, y. Notice the parentheses. With this, we're going to get complicated because we're squaring negative numbers. So we have to make sure we have parentheses to set apart the fact that it's a negative number and to separate it from the minus sign. So 3 minus a -2, well, it's -2 squared. -2 squared is 4 because it's -2 times -2. So this really turns into 3 minus 4, which is -1. And that gives us an ordered pair of -2, -1. 3 minus -1 squared would be like 3 minus a +1 because -1 times -1 is +1. So we get 2, so our ordered pair is now -1, 2. 3 minus 0 squared is just 3 minus 0, which is 3. 3 minus 1 squared is going to turn out the same as 3 minus -1 squared because when we square a number, it doesn't matter if it starts out positive or negative. And 3 minus 2 squared will also be the same as 3 minus -2 squared. So we get 2, -1, and then when we graph that, because we have common y values, you're going to see that we have this curvature. Okay, so is this truly a function? Well, yeah, think about your vertical line test. There I only cross once, 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 once. It doesn't matter where I go, I'm still only crossing one time. So this is another way that a function can look. If it's not a straight line, it's going to have a slight curvature. And just to look and see if this function represents, if this relationship represents a function. Y equals x to the third power. That means x times x times x. Well, here's our input and output. If we plug in -2, how we get the -8 is this as -2 times -2 times -2, which would be -8. Then we would do -1 times -1 times -1, 0 times 0 times 0, 1 times 1 times 1, and 2 times 2 times 2. So if we look at what the graph looks like, again, we have a little bit of a curvature, kind of a unique graph, but let's check with the vertical line test. Here we only cross once, here we cross once, 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 and that pattern continues. So even though it's not a straight line, there's two examples that we just saw of what a function could look like on a graph. If you want to explore more, look up Function Machine on mathplayground.com to play around with functions a little bit. Make sure your notes are filled out completely. On the left-hand side, write questions that could be answered from the material in your notes. Think about the 3 levels of questioning and review your notes. Complete the summary before class.